6F, mixing operations when dealing with fractions. In other words, order of operations. But now we're going to be dealing with fractions instead of just dealing with integers or decimals or things of that sort. Remember, when you're dealing with order of operations, we either deal with PEMDAS or GEMA. And remember, those are essentially the same thing, it's just how you may remember it. Parentheses, exponents, multiplication and division, taken at the same time, going left to right. Addition and subtraction, taken at the same time, going left to right. Or with GEMA, grouping, exponents, multiplication and division, taken left to right. Addition, taken left to right. So the idea here is we're just going to have to remember how do we deal with addition, subtraction, multiplication, or division of fractions. First of all, let's remember that when you add and subtract fractions, you need a common denominator. When you multiply or divide fractions, you do not need a common denominator. Also remember that exponents is just multiplication. You're going to multiply this many of them together. So we're going to follow these processes. We're just going to deal with fractions to do it. So let's get an equation up here and go through and solve it using order of operations. 2/3 minus 1/4 divided by 3/5. Okay, order of operations says we deal with this grouping first, so we've got 2/3 minus 1/4. When we're subtracting, we need to have a common denominator. I've got 3 and 4, so my common denominator is going to be 12, so I'm just going to rewrite this with that common denominator. So I'm going to put a 12 minus something over 12, and I'm going to leave this 3/5 down here. So I need to determine what's going on the top here. Well, if I want to get 12, I started with 3, that's 3 times 4, so I'm going to multiply that by 4. I'm going to multiply the top by 4. So 3 times 4 gives me 12, 2 times 4 gives me 8. And then for 1/4, we multiply that 4 by 3 to get 12, so we're going to multiply the top by 3. So we end up 1 times 3 is 3. So I now have 8/12 minus 3/12. And now that I have my common denominator, I can make that 8 minus 3 is 5/12 divided by, I'll make that division a little longer to clarify that, 3/5. So I've got 5/12 divided by 3/5. Now we're going to do division. I'm going to rewrite this as a division, not with the line, but actually with the division symbol. So 5/12 divided by 3/5. Let me just put it equals over here to make it a continuation. Now remember, when we're dividing fractions, first of all, we don't need a common denominator, but secondly, we don't divide fractions, we multiply by the reciprocal. Remember, keep it, change it, flip it, flop it, or keep the first fraction as it is, change division to multiplication, flip or take the reciprocal of the second fraction, and then solve, do your multiplication. So we're going to keep the 5/12. We're going to change division to multiplication. And we're going to change 3/5 by flipping it. We're going to turn it into 5/3. So now that we have that, we can multiply. And when we multiply, we just multiply across the numerator, we multiply across the denominator. So 5 times 5 is 25, and 12 times 3 is 36. And then if we can, we simplify, but in this case, that's 5 times 5, that's 2 times 2 times 3 times 3. So there is no simplification there. We're left with 25/36. So we're gonna go through the same order of operations, look at the operations, see whether we need a common denominator or not. If we do find it, then do the operation, just step through it. So let's do another one. Three fourths plus 2/8. Actually, let's make that 5/8 plus 5/8 squared times 2/7. So 3/4 plus 5/8, all of that squared times 2/7. So we're going to start out again, order of operations. We're looking for parentheses or grouping, and we got this parenthesis C here, so we're going to have this grouping. We have addition. Addition of fractions requires us to find a common denominator. I see 4 and 8, which I know that 8 is a multiple of 4, so I can use 8 as my common denominator. So I'm just going to come down on this one, so we're going to make this something over 8 plus 5/8. Since we're using it as a common denominator, we can keep it as such. I get 2 times 2/7. So 4 times what gives me 8? 4 times 2. So I'm going to take 3 times 2 gives me 6. So now I have 6/8 plus 5/8 squared times 2/7. So 6/8 plus 5/8, 6 plus 5 gives me 11/8 squared times 2/7. Okay, so we did that, we got our parentheses, now we have an exponent, which it's squared, so that just means multiply 11/8 by 11/8. Now remember, when you're multiplying fractions, you multiply the numerators, you multiply the denominators. So 11/8 is 11 squared, or 11 times 11, which is 121, over 8 squared. 8 times 8 is 64, times 2/7. Now again, we're in multiplication. You don't need a common denominator for multiplication. So we can multiply across. I'm going to save myself a little bit of hassle here. I notice that I've got a 64 and a 2, which means I can divide both of those by 2 and make that 32, and that a 1. That doesn't make a huge difference for me, but it makes a little bit if I'm trying to do this in my head, because now I have 121 times 1 is 121, and I have 32 times 7 instead of 64 times 7. 3 times 7 is 21, so that must be 210. 2 times 7 is 14, so that's 224. So I've got 121 over 224, and then I have to look at, can I reduce this? Now remember, if you're not sure, your calculator can reduce it for you if you remember how to use it. We covered that in one of the other videos. So, but I look at this and I go, 121 is 11 times 11. Prime factorization, right? 11 squared. So 224 is not divisible by 11, and it's not divisible by 121. So we're as simplified as we can go. So at least that is nice that we didn't have to do any more simplification. But if you know how to use your calculator, then you can have the calculator do that for you. Especially if you've got a Casio, it's nice and easy, it'll do it automatically. If you've got another type of calculator, then you have to go through the steps, but it's able to be done. So there we go. So let's move on. And let's look at the distributive property. Remember, the big fancy name for that was the distributive property of multiplication over addition. So basically, what if I have 2/5 times 1/8 plus 3/7? So the distributive property of addition, of multiplication over addition, just says we can take this 2/5 and multiply it by each of these individually. So I can say 2/5 times 1/8. Remember, with multiplication, you don't need a common denominator. So 2 times 1 is 2. 5 times 8 is 40. Plus 2 times 3 is 6. And 5 times 7 is 35. So I just distributed it through. Now you may look at this and go, well, why would I want to do that? Wouldn't I be better off just adding this? In fact, order of operations says that I can add these together. In fact, I should, parentheses, add them together, then multiply that. Now the reason it's important to have this type of process down where we distribute it through is when we start dealing with algebra and we have variables involved. As soon as we put a variable in it, we can't just add those up. If I had this little additional part here that I'm going to take back out again, but if I had that as 1/8 A and 3/7 B, now I've got this A and B, and I can't just add 1/8 A plus 3/7 B. That would be like saying I've got 1 apple and 3 pears. How many apples do I have combined? Well, I only have 1 because I can't combine it with the pears, right? Or what type of fruit do I have when I combine those? I don't know. So I can't do that. So this is just prep work for when we're dealing with these variables. And then once I have this, I can work through it. I've got 40 and 35. So I'm looking for a common denominator of 40 and 35. Well, let's break this up. That's 4 and 10. That's 2, 2, 2 and 5. 35 is 5 and 7. So I just did the prime factorization, knowing that if I want a common denominator, I'm going to need to take the most times that things occur. So I'm looking at 2 cubed times 5 times 7. So let's go 7 times, well, 2 cubed is 8, right? 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. 8 times 7 is 56. 56 times 5 is 280. So 280 is going to be my common denominator. I'm going to put this over here, actually. So we're going to put equals here. So 280, 280. Okay, so 40 times what would give me 280? 40 times 7 will give me 280. So times 7 times 7. 2 times 7 is 14. And don't forget our plus in here. And then 35 times what will give me 80? Let's see. 35 times 8 will give me 280. So times 8 times 8, 6 times 8 is 48. So now I have a common denominator. 14 plus 48 is 62 over 280. And then I can simplify. So divide them both by 2, I get 31 over 140. 31 is a prime number, So unless it divides evenly into 140, which it does not, then we are unable to reduce. So we get 31 over 140. Now, if you're wondering how did I figure out these different things, just plug it into your calculator or do the work off to the side, doing division or multiplication. I just kind of did those as I went along and looked at it and said, well, and actually I can tell you a cheat method that I did here, but don't tell anybody else that I told you about this. If you look here, we came out with 2 cubed times 5 times 7 as our common denominator. 40 has 2 cubed times 5. So all it was missing was the 7. So that's what I had to multiply by, was that 7 that was missing. 35 had 5 and 7. So 35 had the 5 and 7, it was missing the 2 cubed or the 8. So I had to multiply by 8. So it's one of those little tricks that you learn as you go along, and as you get more comfortable with it, you can use that. Okay, actually I'm going to leave this right here because I'm going to use this to introduce the next part of this, which is actually the final thing that we're going to discuss with this video, and that's how do you represent your final answer? I put this into simplest form, which, yes, if you're leaving something as a fraction, then you want to put it into simplest form. But how do you know what you should do? Should you leave it as a fraction or should you leave it as a decimal? If people plug this into their calculator, unless they have a Casio calculator, generally they end up with a decimal result. And so people will plug this into the calculator. I'm just grabbing my calculator here. So you have 31 divided by 140 gives us, and I'm just going to do squiggly here, okay? When you see the double squiggly there, it kind of looks like a wavy equal sign. That means approximately equal to, because the decimal's not an exact value. It's rounded usually. So that's approximately 0.2214285714. Oh, looks like we're going to be good here. That's so 2214285. And then it gets 714. So actually, that's 142857 repeating. So that's the decimal equivalent. This happened to, the denominator happened to be a multiple of 7, so therefore it was able to turn into a 6-digit repeating decimal. Don't worry about how I know that. Okay, so we've either got a fraction or we've got a decimal. Now most of us wouldn't have written this out as far, or when you saw it on the calculator, you might not have realized that was a repeating decimal. I saw it went back to 1,4. It said 0.221428571429. 1429, round that 8 to a 9 because that's a 5, right? So my calculator told me something that I interpreted as a repeating decimal. And the reason I was able to do that was because I was familiar with the numbers we were working with, and I recognized that it's coming out to a repeating decimal. But you may not do that. So how do you respond to these questions? Do you give it as a fraction or give it as a decimal? And the reality is, usually you will be told which to do in some way, shape, or form. Calculate the following and give the result as an exact value. When you see an exact value or exact form, that's what they're looking for, they're basically saying, give it to me as a fraction unless it turns out to be a decimal that terminates pretty quickly. Now, technically, this is exact form. Now, remember that a ratio of two integers will always give you a decimal that will either terminate or repeat. In this case, we saw it repeating. But we don't always want to write all this stuff out. So when you're told to put it in exact form or give the answer as an exact value, generally we're talking about leave it as a fraction. Leave it in terms of a radical if we have an irrational radical. So that's what we're talking about when we say exact form. Leave it as a fraction and stop there. Or we sometimes we need a decimal. In that case, usually we're told to round to either a certain place value or to a certain number of decimal places. So I could with this say, give the answer to the nearest thousandth, right? Which means I'm going to go tenths, hundredths, thousandths, look at the number to the right of it, and I'm going to use that to round. Since it's below 5, I'm going to round down, so I say 0.221. And that would be rounding to the nearest thousandth. Or I could say round to 2 decimal places, which means 1, 2, look at the number to the right of it. So we look at the second decimal place, we look at the number to the right of it, it's a 1 that says to round down, 0.22. So be careful when you're working on math problems or science problems or otherwise to make sure that if you're asked for an exact value, that you leave it as an exact value instead of rounding. If you're asked to round, that you round to the correct place value or to the correct number of decimal places depending on what you're asked. And that's mixing operations and dealing with exact answers versus approximate answers.